3 would work. So that would work, all of these would work, right? Those all have a y of 3, so just draw a line. So this is the equation of a horizontal line. All right. Questions? So if I give you some equations now and ask you to sketch them, you think you could do it? You understand the method, at least the intercept method? We're good on that? Yes? Let's do one more thing, and then I'm going to actually put some problems up and have y'all get up on the boards and get you working. I want you to prove to me that you know how to do these, all right? So before we do that, let's talk about where linear equations would actually appear in the real world, right? Because what's the point of studying linear equations if you're never going to see them anywhere, right? So how are they important? Well, let's talk about, I don't want to ask people questions about their personal life here, but if you're willing to share, does anyone want to tell me if they work a job that pays hourly? I'm not going to ask you how much you make, but does anyone work an hourly job? Yes? Okay. And so you have a fixed hourly rate, you like clock in, clock out type thing, right? Yes? Okay. So, and is that the only money you get from that job? It's just hourly, or do you get some other part? You get tips also. Oh, okay. So that varies. That would be like, it just depends, right? Okay, so what I'm wondering is there anyone here that has a job that's hourly, but they also get paid like some base amount just for being there? No? You had one? So what, you got paid a certain amount, and then you got extra for what? Nothing? Okay. Let me do an example. Let's do just a basic hourly rate first, and then after that we'll add a little something to it. So let's say that you get paid, I don't know, what minimum wage is, I don't know, I'm looking around, I'm seeing like 14 bucks an hour, like no matter what, no matter where you go. So let's just go with 16, okay? Let's say you make $16 an hour. You clock in, you clock out, right? So what you could do is you could figure out your monthly pay, by saying, let's say your pay, P, is equal to 16x, where x is equal to the number of hours you work. The hours you work in that month, right? Your pay is equal to 16 times x. So if you work 0 hours that month, you make $0. You work 1 hour, you make $16. You make 2, right? 32. It's a very simple equation, right? But it is a linear equation in 2 variables, isn't it? I mean, it is. You know what? Let me change the x to h so it looks more like hours, and then I'll put h here, okay? So what we could do is we could do something like this. I could say, graph this for me, right? Graph it. So what you would do is you'd say, okay, I'm going to find the h-intercept, and I'm going to find the p-intercept. See, the key is that you have to understand that it is a linear equation in 2 variables. So all the things that apply to what we've been doing apply here. So if I want to graph this, I can. So my h-intercept, how would I find my h-intercept? Set what to 0? Not hours. Remember, when we're trying to find the x-intercept, we set y to 0. When we find the y-intercept, we set x to 0. So it's always the opposite of the letter. So if I want to find the h-intercept, I'm going to set p equal to 0 and then solve, right? Understand, Garrett? And if I want to find the p-intercept, I'm going to set h to 0. Yeah, set h equal to 0, solve. Let's do these. So for the first one, if p is 0, we get 0 equals 16h. How do I solve that? Trying to solve for h. Yeah, divide 16 still. Divide 16, divide 16. What is 0 divided by 16? 0, right? 0 equals h. That is my h-intercept. Over here, I have to set h to 0, so I get p equals 16 times 0, right? Which gives me what? P is 0. What's going on here? Let's try and draw this. I'm going to need to erase just this. Here's what we have so far. If we put the H here and the P here, so this is the hours we work, this is the pay we make. We found the X, not X-intercept and Y-intercept, we found the H and P-intercept, and they were both the same place, weren't they? 0, 0, so that gave us this. What's wrong? What's wrong with this? We don't have a line yet because this is the same point. Do y'all see that? This is the same point, and how many points do you need? You need 2. So do you see how this intercept method actually didn't work for this method, or for this problem? And I told you we have 2 methods, right? One of them is better than the other, for certain situations. This is a situation where the other method would be better, but we can still get it. Can someone tell me how I could get just one other point on this? Yeah, just plug in some value for H. Just pick a value, like let H be 1. And what would you get for P? 16. So if you plug in 1 for H, you're going to get, I'm going to go off the scale, so I'm just going to put 16 like that. You get 16. And now you have 2 points, don't you? So I could draw a line. Now watch when I draw this line, watch what I do. Why did I not draw the line over here? Yeah, you can't, this over here would mean you have negative hours, right? And in this context of a word problem, you're not going to have negative hours. So it makes no sense to draw over here. Okay. What if we had this situation? When I think of this, I think of like a car salesperson. All right? You have people who sell cars in car dealerships. They usually get paid like a base amount of money every month just to show up. And then they get paid a certain percent of how much they sell. Okay, so let's say that Robert makes, I'm totally making this up because I have no idea how much it is for real, $3,000 per month plus 4.2% of his sales. Find a linear equation which gives his pay in terms of his sales. All right. I think 3,000 is probably a little bit high. I don't know. Okay, so I'm sitting there. I get paid $3,000 per month just to go to the dealership, stand there, and wait for people to come in and buy cars, right? If I don't sell any cars, I'm going to make $3,000, right? And then they'll eventually fire me for not selling cars. But for now, I'll make $3,000. And then if I sell anything, I'm going to get 4.2% of what I sell, right? So if I sell nothing, I get nothing from this. If I sell, $100, well, the car's not going to be $100, but, well, there are some. $1,000 worth of car, then I get, 4%, 4.2% of 1,000. If I send $10,000, then I get 4.2% of 10,000. Make sense? So we need to somehow write this as a linear equation that somehow connects my pay to my sales. We're going to connect pay to sales. So I'm going to start here like this. Pay must equal, well, what for sure am I going to get paid? The 3,000, right? So I'm going to put that here. I'm going to make 3,000 plus, okay, now, how do we say 4.2% of sales? So how do we incorporate a percentage into this? Do y'all know how we can deal with a percentage?
Turn it to a decimal.
To turn it to a decimal, do y'all know how to do that? You move the decimal point. Which way? To the left. How many spaces? 2. So anytime you, right now we're looking at a percentage. Anytime we want to convert this to a decimal, we're gonna move it 2 places to the left. So it'll be 0.042. That's this percentage written as a decimal. Now, what we're going to do is take that number, 0.042, and we will multiply it times however much I sell, right? But I don't know how much I sell, so I'm going to just leave it as a variable. Why don't we call it S for sales? So can y'all see by looking at this that I can start playing around with numbers, right? If I sell nothing, right, 0 here, kills that, and I make my $3,000. But then I could plug in different values like 10,000 or 20,000. I can start to see how much I'll make, right? It's a linear equation in 2 variables. So I can go and try and find the S-intercept and the P-intercept, right? Okay, I'm going to leave it at that. I want y'all to work on some problems. Why don't we do this? I'll just leave this here. Let me give you some other problems. I'm going to write the problems here, and then what you're going to do is you're going to come grab markers. There's markers all over the room, but if they don't work, I've got some fresh ones up here. You're going to grab markers. Everyone's going to be doing their own work, but I want you to kind of like compare your work with the person that's working next to you. Y'all talk, you say, I'm getting this, if you need help, help each other out, okay? The whole idea is to make this so you're not just sitting here listening to me all day, and that you're actually engaging in this a little bit. All right, you ready? So all of these you're going to sketch. Okay, that's the instructions for all these. All right, so first one, start easy. Okay, that's the first one. Next one. Let's go, I'm going to try and confuse you a little bit. Just kind of switch the order of things up, see if that messes you up. Get some fractions in here because I've heard you like them. Let's go. Okay, that one's, yeah, I think that's good. How about this? There we go. Those 5 problems. So the way I want you to do this, get a marker, get up on the board, make your little space for yourself, and then as you're working these, when you finish one of them, raise your hand, just get my attention. I'll look at it, I'll tell you if it looks good. If it looks good, you can move on to the next one. All right? And erasers, I don't know if we have enough erasers. Just don't make any mistakes. How about that? You don't make any mistakes. Y'all can stand up too. You don't have to sit down. See, look, you can get your blood flowing, get some calories burned today. Don't worry about your handwriting, okay? Don't be all self-conscious about that, all right? I'll see if I can find some stuff to erase. Are you not wanting to be on the board? Oh, and then go to, okay. So when you draw your pictures, just make sure that it's easy to see like where it crosses the X and Y, just so I can see the numbers. That's fine. You're good. That's exactly what I'm saying. I want to be able to see that. That's good. Y'all are so quiet. Should we turn on some music or something? What's going on? I'm not turning any music. Someone can turn music on. I'm not turning anything on. Is it weird writing on a board? Yeah, it is, right? Yeah. Yeah, you can look at your notes and stuff. It's not, I'm not trying to like, this isn't a quiz. Okay, so are you done with the first one? So if you're finished, I think you should talk to your neighbors and see if they're getting the same thing. So you're right. Look at your neighbor to the left. See their picture? Look at y'all have the same thing, right? Okay, it's good. Yep, that's good. Try and do the next one just next to it. Don't erase it. Let's see, look around. See if other people are getting the same thing for one.
It's looking like it.
Yeah, it's looking like it. So if it looks like other people get it, move on to the next one. You doing all right? Sure? Okay. That's right. You got the right x-intercept. You just need to move on to the y now, right? I think you forgot the -4 on that, right? So when you graph it, it would have been off a little bit. So you might want to open that scale up a little bit on your x-axis. You know what I'm saying? Like maybe, okay, yeah, because this is your x-intercept, right? So you don't want to put like 5 here. You probably want to do like -1, -2. That way it's out further out. You know what I'm saying? Like out here instead. It's just so it doesn't get all crammed up together. What you got? Is that the second one? Or do you have a problem? Okay. Yeah. Yep. Did you forget the y? Oh.
No, I just didn't put the variable.
Okay, there you go. All right.
So what was that way that you did it earlier? The multiplying at the bottom? I just wanted to try and figure it out.
So
You multiply with 1/5 and then you just flip it?
you flip, whatever's on the left, you take that and flip it and multiply it on both sides. Yeah.
I was just wondering how y'all did that.
Yeah. It's called multiplication by the reciprocal, which is basically the fraction flipped over. Just make sure you bring the negative. Yeah. Yeah.
What about these? Are these okay?
Let's see. Everyone over here has the same first answer as you, so that's a good sign. And then your second ones, people are still working on it. So, yes, your first one's good. Second one, I'll tell you in a minute. Oh, that's your second one. Okay, sorry, I was like, wait a minute, hold on, something's wrong. But there's your first one. Good, good. Yes. Which one is that? Third one? I don't know yet. I don't know yet. Why don't we just see if it is, and just if you're confident with that, you feel good, let's see what other people get. Okay, how about the second one? You see anyone that has that?
The second question?
So you're getting, so look around, because what I want you to do is compare each other's answers. I don't want to tell you if you're right or wrong yet. I want to see, if you look around, other people have the same thing. I think 2 people are getting, on number 2, they're getting a negative on that 12. So did you write it down right? Yeah, you wrote it down, right?
Wait, for two.
Wait, for the second one?
Yeah, I got a negative 12.
Yeah.
You have to change this 3y to a 0 so that way you can subtract 12 from that side. So that way we can.
So yeah, what did you do? What did you do here?
Oh, you know what I did? I know exactly what I did. I was doing it, yeah.
Yeah, so bring it, make it a minus, then there you go.
That's
Okay,
where I messed
yep,
up.
all right. Well, that's why we're doing this, because we want to make sure, like, these are the little things we want to make sure we're doing good with. Okay, you got all 5 there? You feel good about them? Okay, let's let everyone else kind of. Was that your first one? Something's off, right? Let's see, can I see what you did? So you found you let y be 0, and then, I see what you did. I think I see what you did. So we started with this, right? And you were trying to find the x-intercept, right? So I'm going to put this down that way. Okay, to do that you set y to 0. So when you do that, it'll be negative 5x and then equals 20, right? Plus 0 equals 20. So plus 0 equals 20. I think you had that written down, yeah? Okay, and now this is gone, so negative 5x equals 20. And then divide, and you got negative 4. Okay, that's that. That's good. This one though, let's see. When you did this, you let x be 0? Is that?
I would want to be 0.
To find, so this was the x-intercept, right?
Yeah.
So to find the y-intercept, you set x equal to 0.
Yeah.
And when you do that, you get y is
Yeah.
20. 20.
Yeah, because, okay.
But you put 25. Okay, yeah. That's the first, that's right. Now, this though, see, look, this is the x and this is the y. This is the x. So you got them backwards.
Okay.
Got it? Okay. Do you have all of them? Okay, the two of you have all of them. Garrett and Ashley. Yeah, Ashley. Y'all have the same. So maybe y'all can compare and see if y'all have the same answers. Do y'all look, does it look right? Yeah? 15 and 6 on that y and x-intercept? On the, yeah, the third one? Okay. So let me see what you did. I'm just curious. So you did, no, it's fine. That's actually pretty neat. X is 0. Oh, you divided by 1/5. Okay, and then multiply by the reciprocal. Okay, that's good. Yeah. If y'all are good, you can sit down, you know, mess around on your phone for a little bit. I'm going to get your homework assignments up here in a minute. Okay.
Who has them all done to compare?
I'm sorry?
It's finished.
Okay, so you got, let me see. It's the first one. 12 negative 6. That 4. Label that one, the y-axis, label that 4 on the y. Left, on the one on your left. The board right there. Yeah, the y-intercept, label that as a 4. Yep. And then, now I think the third one is off a little bit. So let's see, that's this one here. So where did you do that one? Right here?
Yeah.
So you first to find you set y equal to 0, you did this.
Yep.
You divide, okay, here, are you dividing by, you multiply by 2.
Yeah.
So x is 6, okay. And then over here, the negative 5, let's see, multiply negative 15. So what are they getting? Hold on, positive 15, did you write it down right? Yeah? Yeah, I think you're good here. Yeah. This is the first time I'm looking at this. Where did you get your positive 15 on your y-axis? Garrett, on the third one, where did you get positive 15 from?
I didn't carry the negative.
You know what? Yeah, see the negative? Okay, you see in the problem it's a minus, so that would be a minus there. So you have to multiply both sides by negative 1, you know what I'm saying? Negative there and negative on the other side. Yeah, so it'd be down to negative 15. Yeah, good. You doing okay here? You got negative 15 and 6. Okay, you're good. Yep. How are we doing over here, sir? You working on the second one? Corin? You got the first one, right? 420. You're all right with that? Okay, so here you set y to 0. So x is negative. Good. And then here you set x to 0, divide 4. Okay, yeah. Yeah, looks good. Just make sure you put the x on the x-axis and the y on the y-axis. Whoa. Let's see. Say again?
Does this one look right?
Yeah, let me see. Negative 12 and 4 on the y. Yeah, uh-huh. Yeah.
What do I start to do with this one?
Okay, so on that one, so here's the thing. On this picture, what I would just make sure is that when you graph this, you know, label this for, and then on the test. That way it's easy to see what's going on. So on this one, you have a lot of options, but if you're going to find the x-intercept, set y equal to 0, right? Which would kill that. So you get 1/2 x equals 3. So what do you think? Uh-huh. 2 here, 2 here, right? And that would give you x is 6. And then do the same thing for the y. Just be careful right here for that negative sign when you do that. Okay. You good?
Yes. Sir.
Yes?
I'm just getting my answers again.
Where's the third one? This is
This is the third one.
negative 15, 5. Yeah, I think that's what other people were getting. Negative 15 and 6, right? That's 6.
Yes.
Okay. All right, you doing all right here, ma'am? Oh, you're doing the vertical and horizontal one now? Okay. Third one's there. Okay, good. We're just going to go a few more minutes. So if you're not finished, it's okay. We're about to stop. Just, this looks good, good, good. Yeah, it's all good. Okay. Yes, 6 and negative 15. So you graphed them there. Okay, let's wrap it up. We still have time. We're gonna keep going here, but go ahead and have a seat. If you want to take a picture of your own work, now would be the time. If not, just you can leave it there. I'll erase it later. Okay, everyone's got that. Now what I'm going to do in the next 15 minutes is I want to talk about the other method. So honestly, do you feel like that was helpful at all? Or was, I mean, because watching me do it is always easy because, I know the path, right? What I noticed just by looking around, the things that I would work on for y'all, right? The things that I'd work on is when you're doing the problem, write down x-intercept, right? Like say what you're doing and then do it, and then y-intercept. And that way, when it comes to going to review, look back at your notes, look back and see what hey, what was I doing there? It's easier to read it if you have some description as to what you were doing. That's what I noticed the most. Okay, so the second method to sketching a line, the second method is called the Slope-Intercept Method. Okay, the Slope-Intercept Method. And the Slope-Intercept Method works like this. You're going to take your equation, you're going to solve the equation for y, right? That's the very first step of what's called the Slope-Intercept Method. Whatever linear equation you're given, you want to solve it for y, meaning you want to get y by itself on one side of the equation, all right? That's the hard part of this method, is getting that done. Okay, now I'll show you an example. Once you've done this step, once you've solved the equation for y, it's going to have to look like this. In other words, it's going to have to be some number in front of x, and then plus, and this could be a minus, okay? But this will be another number. All right? So you will start with your equation, you'll solve it for y, and then guaranteed it's going to have to look like this. Y equals a number in front of x plus or minus another number. Once we're here, sketching it is very simple. Once we can get it to this. Now, what this actually turns out to be is this number will always be what we call, that m is what we call the slope of the line. And it is always your rise divided by the run. I will explain this as we do an example. And then this number right here will always be your y-intercept. Always. So it's just this very nice property of linear equations that if you can solve for y, then the number in front of x will always represent something about your line. It tells you the pitch of the line. And then the number out here tells you where you hit the y-axis. Guaranteed every time. So let's do an example, all right, so you can see this in action. And like I said earlier, I'm not going to care which method you use. Use whatever you want. So why don't we'll do the first problem that we had that I gave you to do just now. So it was negative 5x plus y equals 20, all right? Let's sketch this line. And let's use the slope-intercept method. So my first goal is to get y by itself, all right? So I see I have y right here. I'm going to try and get it by itself, so I need to get this negative 5x off this side. So what I'm going to do is add 5x to both sides. And that will get rid of it here, and I'll have y equals, now, you cannot add these two together, right? 20 plus 5x, they're not like terms. We talked about that last class. So the only thing you can do is write 5x plus 20. And notice the way I wrote it. Notice the order I wrote it. I put the x term in front of the 20 because I'm trying to get it to look like this kind of master formula for slope-intercept form, which is this. My goal was to reach that point. And do you see that we have reached that point? So what is, let's see, Keegan, did I call Keegan yet? No. Keegan, what is m for us here? 5. M is 5. So the slope of this line is 5. And Keegan, what is the y-intercept? So the y-intercept will always be the number out to the side, which would be 20. Okay, 20. Everyone got that? So how do we use that to graph the line, right? What do? Well, here's what we do. We go, draw, graph.